acceleration, which actually is the end of our physics section before the start. Okay, we're going to come back to the physics after the start. But it's basically the end of everything we need to know about physics for the STAR test. Now, your essential question is, what are the similarities and differences between speed and acceleration? So you should be on page 157 of your notebook. Alright, so let's talk about speed. Speed is just basically distance divided by time. The units vary depending on what units they give you. If they give you the distance in meters and the time in minutes, then it's meters per minute. If they give you the distance in miles and the time in hours, then it'd be miles per hour. Okay? So the units on speed are going to vary, so you need to make sure that you pay attention when you're doing these problems. And pay attention to the units that they give you. Okay? So it's all, since it's distance divided by time, it's going to be miles per hour, meters per second. Okay? So you need to make sure that you pay attention to that. Now, when we think of speed, we tend to think of something called constant speed. Constant speed is basically speed that doesn't change. Okay? Now, can you go to constant speed forever and ever and ever?
No.
No. Eventually you're going to have to brake or you're going to have to speed up, right? But constant speed is basically in a specific time, you go at a specific speed and it doesn't change. When we think of those graphically, because when we start looking at speed and acceleration, you have to know how to calculate them. But more importantly, you need to be able to look at a graph and know what you're seeing. Okay? So when you look at speed, we look at a distance time graph. So we see how far it went in a specific time. For constant speed, that was going to be a straight line. In a distance time graph, you see a straight line at an angle, it is going to be constant speed. Okay? So, in a distance time graph, you will always see constant speed as a straight line with a specific slope. Okay? Now, the steeper the slope, the greater the speed. So if we look at this one, here I have a graph in which I have three lines, A, B, C. Are these constant slope, Elena? Are they constant speed? Those three lines, are they constant speed? Why do I know they're constant speed? Well, why do I know they're constant speed? Because they're what? Because they're a straight line, right? So I know that's constant speed, right? I know that's constant speed, I know that's constant speed. They're all straight line and have a slope. Correct? Alright. Now by looking at the slope, you can see which one is moving the fastest, which one is moving the slowest. So if I look at A, okay, it moves a specific distance in very little time. Compared to C, it moves a specific distance in a lot of time. So which one is my fastest speed? A, B, or C? Antonio, why do you think it's A?
Deeper.
Okay, so, but what does that tell me about distance compared to time?
There's more distance in the amount of time.
So, let's say this was 10. I make up a number, right? Let's say this was 10. So this one went 10 meters in, 2 seconds?
Yeah.
Right? Compared to this one, which went 3 in much longer time, right? That's how you know this one is the slower speed. Because if you look at this one, it went very little distance in a lot of time. So if I have very little distance in a lot of time, and I divide those two together, isn't that going to give me a smaller number? Right? So make sure you look at that. So once again, which one is the greatest speed on this one? A. Okay. Now, obviously, since we don't go to constant speed all the time, when we look at speed, we look at average speed. Average speed is just the total distance we traveled in the total amount of time. Because when I drive to work, it's not like I can go 60 miles an hour starting from my house to here and get tickets. Okay? So I have to go at different speeds, correct? So if I wanted to know my average speed, I would take the total distance, which I think is like 38 miles or something like that, divided by the total time it takes me, which is about 45 minutes. Okay? That would give me my average speed. Because I'm going to have something that looks like this. I'm going to have times where I go faster, where I go slower, where I stop. Because I can't just run all the red lights. So I have to stop at the red lights, right? So, if you look at this is a distance time graph. If I want to know the average speed of this, I would have to take the entire distance divided by the entire time, and that would give me my average speed. So, when you look at these, you need to know what's happening in each line. So if I look at this section right here, it's a straight line with the slope. So that is what? Constant speed. Okay? Now here, over this amount of time, I didn't move at all. So what is that?
Constant. At rest.
Stopping. At rest, not moving, right? So right here, look at this entire line. I didn't move at all. So anytime you see, is that horizontal? A horizontal line on a distance time graph, it means not moving. Okay? Then I started back up and I started increasing my distance in a given amount of time. So this is again constant speed, right? Yes?
Yes.
Okay. Then I did what?
At rest again.
I rest again. Then I did what?
You move that constant speed.
Constant speed. Now, what about this one?
Constant speed.
Constant speed. But why is this one coming back?
Because it's going back.
It's slowing down.
It has nothing to do with those ones. It's going back where?
Where you
To where I first started.
So it's
So basically, this is me. Let's say I go for a walk. So I'm going for a walk. Then I stop at the corner. Then I continue another block. Then I stop at the corner. Then I continue another block. And then I walk the 3 blocks back to my house. So this is just coming back to the same original position. Give me a second. Because this is distance. Okay? So I'm walking away from my house, I stop at the block, I'm walking away from my house, stop at the block, walking away from my house, come back 3 blocks. So this is still constant speed, it's just you going back to your original position. Okay? And question?
So since you started at 0, then you're gonna, if it goes to 0, then you're stopping.
Yes. So if the line comes back to this line, I basically came back. Okay? So basically, that would look like something like this. So I walk, I stop, I walk, stop, I walk, and I walk back. All the way back. Okay? That's what that line is saying. Alright? Now, looking at these 3 lines. This one, this one, this one. 1, 2, 3. Alfredo, which one is the fastest one? 1, 2, or 3? You think it's 3? I would probably agree that would be 3. Okay?
The 1 and 2, the 1 and 3 look real close.
Yeah, 1 and 3 look pretty good, but I would agree it's 3. Alright? So which one's the slowest one?
2.
The 2, right? Now what if I'm looking at all these lines? Which ones could be the slowest one?
The ones at rest.
The ones at rest. Is the
They're not
speed
moving.
is,
0.
okay? So make sure you kind of pay attention to it. So any questions over any of those lines and what they mean? Alright, so now we're going to look at acceleration. Acceleration is the change in velocity. So let's review. Acceleration is the change in velocity. So David, give me an example of acceleration. Okay. So walking. walking faster, okay? Ivan,
Turning.
turning, and Tristan?
Running.
Well, where I said walking faster, turning, where's the other one?
Driving a car.
Nope.
Stopping.
What's the other?
Well, if I stop, that
Slowing
means
down.
I did what to my speed?
Slow down.
Slow down. So, going faster, slowing down, or turning is acceleration, right? Because in all three of those, my velocity changed. So, let's look at what that looks in a graph. You already know what it is. So in a distance time graph, we're still looking at a distance time graph. We see that as time goes by, I start going faster and faster and faster. Acceleration graph will always be a curved line on a distance time graph. Okay, so on a distance time graph, it's going to be a curved line. Now this one, what's happening to my acceleration?
It's decelerating.
Is decelerating. So in this one, I'm going faster, going slower, okay? You will always have a curved line in a distance time graph. So constant speed was what on a distance time graph?
Straight.
A straight line. Acceleration is a
Curve.
curve, okay? So this is distance time graph. Now remember we had a question on a benchmark, and it asked you which of the following is constant speed, and a lot of you got it wrong, okay? Because they not only gave you distance time graphs, they gave you speed time graphs, so that's what we're going to look at now, okay? So up to this point, this top portion of the notes is distance time. Make sure that you pay attention to that. I would circle the x, y axis on that. You need to pay attention to that, okay? All these that we've gone over are distance time graphs. Now we're going to look at speed time graphs. So speed time graphs show you the change in speed over time. So distance time graph shows you distance to time, right? Speed time graphs now shows you speed to time, and things look a little bit different. So let's look at this. Constant speed is always on a speed time graph a horizontal line. Because think about it. Right here, my speed was, let's say, 5, right? What's my speed here?
5.
What's my speed here?
5.
What's my speed here?
5.
Isn't that constant?
Yes.
So, in a speed time graph, a horizontal line is constant time. Constant speed. So, looking at these two, because both of these are constant speed, right? They're both horizontal lines. Which one is faster? You got A or B? A. Why? There's no distance. It has more speed. Because if this is 5, this has to be probably 10, right? So in this case, you can tell which one is faster by basically which one's up higher on the ground. Alright? So questions over this. Now, this looks very similar to what on the distance time graph?
Stopping.
Stopping. That's what's going to mess you up. If you do not pay attention to the XY axis. On a speed time graph, a horizontal line is constant speed. On a distance time graph, a horizontal line is
Rest.
at rest. That is why you need to pay attention to the XY axis. Okay? So now let's look at acceleration. Acceleration is always a straight line on a speed time graph with the slope. Because right here, at 1 second, my speed was 1, right? At 2 seconds, my speed was 2. At 3 seconds, my speed was 3. At 4 seconds, speed was 4. So isn't that increasing speed? So that's acceleration. Now what does this look like in a distance time graph?
Constant.
No.
A constant speed,
Yeah.
right? Doesn't this line look like this line?
Yeah.
They look exactly the same, right? But they're two different things. Here, in a distance time graph, it's what?
Constant.
Constant. Here, in a speed time graph, it's
Acceleration.
acceleration.
I want to see it
So do you see the difference on those?
Yeah.
So do you see how important the x, y axis are? Technically, it's really more the y axis, because the x is always the same, it's time. You really, really, really need to pay attention to the y axis, and is it giving me speed, is it giving me distance, because that's going to change what it is. Alright? So let's look at this bottom one. So, speed, time graph. This is going up. It's a horizontal line, so this is what? In this case. What's happening here?
It's
Accelerating, so it's going faster, right? Then it becomes a straight line. Here it's what?
Constant.
Constant speed. Then it comes down, so the speed is decreasing. What's happening here?
Slowing down.
It's slowing down, or we would call it negative acceleration, right? Here, then I have a line right here at the bottom.
Constant.
Constant speed. Then
Acceleration.
acceleration.
Constant. Negative acceleration.
So do you see how different this graph is explained than the other graph?
Yes.
You really need to pay attention to that y-axis. I don't know how many times I've said it already. You really need to pay attention to that y-axis. Because that is going to change your answers if they're asking something of you. Okay? So be very, very careful. Is it asking me for speed time? Or is it giving me distance time? Because those two things are telling you two different things. Okay? So any questions over any of those? Good?
yeah.